welcome to the technology track. This is the APAC block. So I'm really pleased to be your track leader to take you into the rest of your day, perhaps the rest of your evening. Our next speaker in the technology track is Salley Chuen. And I'm really pleased to have Salley here to join us today. She's going to be talking about 3D printing in Singapore and what that looks like. She's the application and sales manager of Creates 3D. It's an authorized distributor of Stratasys products in Singapore and Vietnam. Salley holds a bachelor's degree in business administration from the University of South Australia, as well as a background in chemical process technology. Salley has 16 years of past sales experience, and it has all revolved around the distribution of equipment and production and manufacturing industries. So she's got a fantastic background, and in 2013 joined Creates 3D and really drove the demand and adoption of additive manufacturing in Singapore. And so with her background and understanding of the market in Singapore, Salley now heads up the sales team to advocate for applications in 3D printing. Salley has a vast knowledge of 3D printing technologies and their various applications, and she's no stranger to sharing her advice and opinion. So I'm really looking forward to hearing what Salley has to say. Thank you so much for joining us. Salley, would you like to share your camera, please, or turn your camera and mic on? Salley, if you're having trouble, just send me a message, but I will see if I can also pull you up. Okay, you should be allowed to turn your camera and your mic on now. I apologize.
Okay, great. Hi. Thank you, Alex. Yeah, thank you, everyone. It's like 8 a.m. over here in Singapore. Okay.
Take it away, Salley.
Yeah. Let me share my. All right. Yeah, can you see my screen? Alex?
Green, it looks fantastic.
Everything's good?
Yeah.
Okay,
Take
great.
it away.
So, okay. All right. So I shall start. Okay, so today topic will be mainly on the stories about 3D printing. Okay, this is really my first time doing on an international platform. I have always been doing this for Singapore only. Hopefully today, whatever I'm going to share is going to be useful to any one of you out there, right? So very quickly, the content about what I'm going to talk about is a little bit about who is Creates 3D and what we do, and a little bit about myself. And of course, manufacturing of AM today in Singapore, or at least today what we see in the market. And then I'll cover 3 different case studies that I find very interesting and probably will be interesting for you guys too. So a little bit about Creates 3D. We have more than, over the years, we have more than 200 over installed base around Southeast Asia. So today we have already invested about $3 million just on marketing for 3D printing. So we believe greatly in educating the public about what is 3D printing. We have around 7 different technologies, including 3 types of metals. The rest are mainly polymers. So over the years, we have 4 different divisions. One is solely in service printing for medical. So we have another service bureau for ceramic printing. And then we have, of course, a technology team, which is mainly in machine sales. And recently we developed a new division that's mainly focusing on services and consultancies. So I would say over my 10 years in Creates 3D, I have more than 100 over different projects. So working with different people with different fields. So just a little bit about what I do over here. So very quickly, I want to start with manufacturing of AM today. The three different type of applications that I've selected that we see as very commonly used, adopted in most of our customers is mainly on end use parts as well as toolings and low volume productions. So, well, additive manufacturing, this is normally the sweet spot for low volume, high complexity. So, like I said, we have identified three different types of applications, mainly for end use, tooling, and low volume productions. In the recent years, we see more adoptions over here, and definitely it makes more sense because it fits into the category of additive manufacturing, whereas it doesn't really complement the conventional manufacturing. Okay, so just to walk through on the stages of product life, usually this is how we use additive manufacturing. In the past, people believe that additive manufacturing can only be used for concept designs, for prototypings, for very low or non-functional applications. But what we see today is there's a lot of requirements or demands coming from more test modes, functional testings, even jigs and fixtures. I think jigs and fixtures is one of the biggest applications we see in the recent years that customers are coming to us looking for low volume productions and all these things. So that's why the focus for today, I will only talk about three different type of or three case studies that's mainly focusing on this aspect, which is tooling, jigs and fixtures. Okay, so I'm going to go very quickly into the three stories. This is, I would say, the first stories will give you, it kind of change your whole mindset about what 3D printing is, or at least the customers that we are involved in. The second story is we actually deliver more than what the customers expect. So yeah, the third story is mainly on how we simplify the whole tooling request from our customers. So quickly, I'll go into the first case study. We work with this company called Fidel Engineering. They are basically a tooling house. They produce a lot of jigs and fixtures, and they specialize on in aerospace industries. So they came to us asking for a solution on how AM can be integrated in for metal, because they're spending a lot of money just on mold forming for low volume, especially for aerospace industries. So we came up, this is some of the pain points, very labor intensive. The cost is very high because mainly they have a lot of skilled workers. And the lead time is usually very long. So they are restricted in the sense of mold designs, especially when it comes to progressive stamping tools. They need multiple molds to do that. And if they stamp if the metal sheet is actually very thick, they need to, the mold will get destroyed very, very quickly. So the requirements for them is how we can actually integrate AM or redesigning into their process for low volume productions, and bring down the cost of tools as well as the time to market. So yeah, the top section is talking about the traditional way of how they are doing their mold stamping. Yeah, the molding, the mold, how they produce the mold. So from machining all the way to forming the mold takes around 7 days, and they need 4 different types of skilled workers to do this. The process is actually very skill dependent, and if one of the workers is down, they're actually trapped with longer lead time. Whereas when we do the tool designing, basically we only need one designer and one operator. That's the maximum hour requires. So after listening to what they want, we use Stratasys Fortis machines to produce this mold. And the whole idea is to produce a modular mold, meaning that if you can see, this is the final design. So we understood that certain section of the mold wear off very easily. And usually for whole metal molds, they need to dispose the whole thing. And this is actually cost to them. So we thought of why don't we look at in designing a modular insert. So customers is quite surprised that they can, AM can actually do this, and it has never crossed their mind that they can do inserts, or even if it's usually very, very expensive to do this. So, we produced two type of inserts, or two material inserts. Basically, is to test which one will last a longer time. So, of course, PCABS is a real thermoplastics. This material lasts longer, but due to its ductility, we may not be able to get that curvature as much as we want to. So I would say PCABS is definitely not the best material. Digital ABS from Stratasys polyjet machines definitely gives you a better forming on a better sheet form, but then this is a little too soft. But overall, actually, it's all about the choice of materials, I would say. This application is really very interesting. We did about 100 shots of stamps, and then we noticed that the mold starts to wear off a little bit, but customers is very happy because the part printers are really within their own tolerance and very ideal for their own low productions. Usually they only requires like maybe about 40 to 100 sheets. So, but like I said, during this whole process, we noticed that PCABS is probably not the best material to go for because it's too ductile, and we noticed that there is some spring back. So if given a choice again, I would rather choose a polycarbonate, which is a more rigid material for these applications. Yeah, but the whole concept is definitely adoptable in the whole process. Okay, so the next story is mainly on Universal Robots. So Universal Robot approaches with a collaborations for a new, back then it was like maybe about 4 years ago. This project is really quite some time back. So they had a new UR10 back then. So they wanted to design a suction gripper for food packaging, and they want to they have totally no idea of what they can produce in this case. So they came to us and they asked us to do a design for them. And after understanding what UR10 is all about, it can turn 360 degrees. So we decided to do a multi-axis suction gripper for them. And again, so this is traditionally how end of arms look like. It's usually very bulky, very heavy, and a lot of sharp edges, and it's very rigid, and it's really not so adjustable. And usually the payload, it takes into their whole payload. So for example, about 10 kg payload, and easily the end of arm will take about 3 or 4 kgs sometimes. So this is part of the requirement, is to reduce on the payload itself. So in order to show that 360 degrees, as I mentioned, we intend to design something that is multi-axis and can turn to demonstrate that 360 degree feature for them. So we actually chose Stratasys Fortis 450 MC to print this, because it can print in polycarbonates. So this is how the concept designs work like. The whole process actually took us about 1 week to come up with the final design. So we want to optimize the whole design based on how FDMs is supposed to work. Because usually for professional printers, there would be a lot of support material generated in the air channels itself. So if we do it in a 45-degree angles, we can actually eliminate the support materials, and we work on the toolpath itself to produce a tighter Z-axis, so that we don't need to compensate for the air loss. So of course, having a very powerful software like Insight, it helps us a lot in terms of toolpath manipulations. So using all these features, we managed to come up with the part itself without a support material generated in the center. So it kind of reduce on the time to market, and we actually program to embed inserts so that it gives a tighter feel. There's no need for the users to plug in, plug out, and all these things. So we try to reduce on the amount of removable components. So this is how it looks like. Traditionally, it one end of arm will takes about 200 over different components to make it up, and you need a lot of experience in order to know what to draw, what to include into the whole end of arm. But in this case, we have zero experience in designing an end of arm, and we came up with this design in 1 whole week. So we brought down the weight of the end of arm to 175 grams. So of course, the customers is UR is definitely very, very happy with this design. So this is a short video on how it's being used. So there was I think after this final design, we actually did some modifications, further modifications on the end of arm to include image, a camera on the side. So we create something that is attachable, detachable for them. So yeah, this is quite impressive. So okay. So yeah, I'll move into the third project, and this third project is actually very, very recent. We can't reveal who is the end user because we signed an NDA with this company, but they came to us with a problem with labeling gripper. So they bought a lot of robots in the whole process, and because they're dealing with consumer products and with the e-commerce today, actually customers are buying different type of items in a single order. So for them to deliver to the customers, sometimes when they ship overseas to Singapore, they need to do relabeling, and this relabeling can be quite labor intensive. At the current moment, I think all the relabeling, I'm not so sure for other countries, but maybe for Singapore itself, I'm quite sure that they are all using manual labeling. So it can be quite really intensive, and it takes a very long time. And if this distribution is different items in a single box, they need to make sure that the labels are all available and labeled on the go. So they came to us and say that they want to design a label gripper that is adaptive in a way that it doesn't require a lot of programming for the robot to move in all axes. So they just wanted to be able to label all type of sizes in a single movement, which is downwards. So this is mainly for low volume. So we decided to make use of whatever resources that we have, whatever we learn, and we came up with adaptive robot gripper that is able to grip different type of labels. So they give us about 4 labels. So you can see that it's quite challenging for us to be able to come up with a label gripper that is able to do all this type of labels, and the bottles and the shapes are all different. We locked down to 3 different type of bottles, or no, one bottles and 2 type of tubes with different width and length. So, but still, each type of tubes, we need to make sure that they can label at the edge of the tube as well as the center of the tube. Tube is actually lying down and the bottle is standing up. So maybe easier for us to show you how it looks like. We came up with the design in 15 working days actually. This robot is able to adapt to the shape of the bottle or the tubes when it comes down. We actually make use of a few different type of materials, mainly nylon 12 carbon fiber as well as TPU. And we made it in such a way that it's modular and easy changeable. So every component in this gripper is easily replaced and removed. You just change whichever wear off. And even the suction pad is also 3D printed. So maybe I can show you the video. I can't show you the whole process. Yeah, this is we designed two different type of gripper, one for bottle and one for tubes. So this is the one for the bottle. Okay, so we brought down the whole weight to less than 1 kg. So the robot that they are using is a ABB robot. That is only like maybe, if I'm not wrong, it's about 6 kg payload. So with only just one movement, we are able to comply to the customer requirements, and yeah, of course, they are very, very pleased with this. So the whole bomb rings only consists about 18 components. I would say, yeah, this is really something that is interesting, and we're going to roll out after we get the full patent for this. So yeah, I cover my full presentation slide. So if there's any questions, feel free to let me know.
Hi, Sally. Thank you so much for that. That was really great. I was actually mid typing in a comment just to say that the ability to adaptively you go to different surfaces is really impressive, and you can kind of see how, or you can definitely see how that would be such a valuable thing, to not have to, reprogram and retool for, like a small change in a product line. We've definitely got a couple of questions. So, and, please feel free to go over to the Q&A tab and put in any other questions that you might have, or even go and upvote some of the questions that you quite like the sound of. So the first one is, what type of software tools do you use to support your design process?
Oh, what is the highest upper temperature used for polymer-based AM for mold and tooling?
Sally?
Yep.
Hi.
Yes.
Sally.
Yes,
I'll ask the questions. You don't need to worry about the Q&A box. That was more a message for the audience. So, so the first one was, what type of software tools do you use to support your design process?
Oh, we use a lot. We use Rhino. We also have Creo, but mainly we use a lot of Rhino.
Right. Okay. Rhino is not overly common. It's very organic too, isn't it?
Yeah. I mean that's okay. To be frank, my designer is actually an animator, so he's very, very good at organic drawings, which is actually help us a lot in our designing process. So I'm not really restricted to how mold is supposed to be made, or very squarish design. So yeah.
Yeah, fantastic. And so do you have any sort of like a finite element analysis capability that you use, or is it more a DFAM from a design angle only?
To be frank, in order to help come up with all these ideas for customers, we need to have very, very strong applications knowledge on how our printers is able to how we are able to work with our printers. Then we come to the design itself. I would say the design is really it's not that difficult if you really understand how the printer, what your printer is able to is capable of. Yeah. Does that answer your questions?
Yeah. No, that's great. That was actually my own extension of the original question. So the next one is, what are the trends that we should look out for in the next 5 years? And maybe, I'm kind of interested to know, what do you think the trends are in Singapore in particular? Because it's a pretty unique ecosystem there.
Right now, after talking to so many people, they're all looking into low volume production. They're looking into how they can go into 4D printing. Or I have no idea why they want to go into 4D printing. Because frankly speaking, to me, 4D printing is all about deformities. So if your material can deform very quickly, it can definitely comply to the 4D printing technology, but it's not going to last you for very long, end of the day. But tooling is definitely something on most of the customer mind, because maybe just an example like Rolls-Royce itself, just the whole production floor, tooling on its own per year easily is about $1 million. So I mean, not everything can be replaced with, or you need to replace with metal. There are a lot of parts that I see in the market right now. Actually, it can be replaced with plastic. It's just that they have been traditionally manufactured in metal, that's all. But it can be, there's a lot of benefits to do it in plastic, and there's more cost savings. Metal, I would say metal technology is very mature right now. You can take up metal parts if your product is high value. Yeah. End of the day, we look at ROI. This is what I feel. Yeah, but jigs and fixture tooling, low production, low volume production is definitely the way to go.
Yeah, interesting, and it plays so well into the additive manufacturing value proposition as well. The next question was, do you work with a lot of different materials? Do you have a testing lab that you work with, or perhaps do you have testing lab equipment in house?
Frankly we don't, but because we work with the printers for so long, and we understand how the properties of the materials that we choose. Plus, over the years, me myself is in chemical process, so we analyze the material properties itself, and I would say, okay, Singapore is a tropical country, so it's a little bit different from Europe or wherever the places are lower in humidity. Over here, we need to factor in humidity, UV, heat, how these three components will actually affect your part properties, on top of the thermoplastic based properties. So I would say, whatever that we have done or proposed to customers is mainly based on our own experience. We have not done any testing for the parts itself, but the customers are free to do that on their own. And if they can feedback to us, we can actually replace with other materials if necessary. But half the time it really works.
Yeah. I think you make a really good point there too around the environmental conditions that you experience in Singapore. It is a really humid place, and humidity, it makes such a big difference in terms of from everything from your materials handling through to processing, and then final part properties. So that's a really good. Next question is, how common are robotics in Singapore, and are you seeing robotics rolled out more broadly for many different tasks?
Singapore invested a lot of money in robotics, so there's a lot of grants happening over here for robotics. But okay, based on what I see, to be frank, there is a problem with programming. It's not about whether is the company able to afford a robot. A workshop easily can have like 30 to 50 to even 100 CNC machines, and each CNC machine easily costs about 200-300K or even a $1 million CNC machines. But you don't see them integrate robots so easily. It's all about the manpower, the skill set. Even over the last 2 or 3 years, although there is a lot of talk about robotics, but I really don't see a lot of integrations. But definitely there will be a growth. Definitely there will be a growth, but I don't think it's going to be very significantly high. No, I don't think so.
What do you mean by not a lot of integration? So it's just sort of not being used that heavily that you anticipate it will in the future?
Okay, I would say they probably will integrate robots, but it is used for very, very, very low skill. Okay, example. There is a coffee house in Singapore that is really very famous. So there is a huge chain of coffee house. So they bought robots just to do repetitive action of making coffee. So it's a very low value job, or is very simple job. It's very repetitive. It's not something that is realistic to like production line. So yeah, I mean I've seen workshops that bought like 20 robot and probably only one is working.
Yeah,
So
I
yeah.
mean, I don't know if a robot's making my coffee, I miss all the chat with the barista. All right, next question, which is our last one, and then we'll move on to our next speaker, which is what are the highest / upper temperatures used for polymer-based AM printing for mold and tooling parts for Create's customers?
Actually, I don't quite
Have you got
understand
that?
this question.
So what are the highest temperatures that I'm guessing that your customers' service requirements. So if you're delivering them, molds or tooling, what are the service temperatures that are required of those? Are they high temperature or sort of what's the max? I guess it's kind of more about the questions about material performance under higher temperatures.
Okay, for the stamping application, there is no requirement on the heat, but like you have seen, there is a spring back, so I would say we should be considering rigidity rather than temperature. So if you're talking about injection molding, usually we don't use FDM technology, we will use PolyJet, but the problem with PolyJet is it's not able to withstand more than even 100 degrees. So even when I go to a certain thickness, I can probably withstand about 250 degrees, but if it's a direct heating on the mold, it can cause the mold to degrade very quickly. So I would recommend not to get a injection mold that heats the mold, rather just inject heated materials into it. I mean, there is some injection molding machine that doesn't heat the mold. So something like Baby Plus, that will work very well for PolyJet materials, even if your injected material is 200 over degrees. So I would say, end of the day, it really depends on what is the end applications. For the last story on the adaptive robot, that has zero requirement on the heat as well. So we use whatever that we think is suitable for the local environment.
Yeah, of course. Thank you so much, Sally. We're right out of time, but thank you so much for your insights, and I'd love to pick your brains a whole lot more about all the things that you do. But that was a fantastic presentation, and really great to hear a little bit more about what's happening in Singapore too. Thanks for joining us.